just keep this as it is. So we are going to decide the input shape. So we know the shape of our image is 28 cross 28. So if you just type x train dot shape 1 and 2, so you will get what? 28 comma 28, and comma 1 means this is a grayscale image. That's why 1 is written. You understand, right? A color image is then it would be having 3 channels. If it is a grayscale image, it has only 1 channel. Then we are going to convert our variables train and test into some floating precision, so that during multiplication and division the number would be float in the float form actually. Okay, so we are going to convert their type into as float, and then we are going to normalize these data sets by 255. So why we are doing this? The image will be having all the pixel values ranging from 0 to 255. So why there is a need to normalize these images with respect to 255?
To reduce
So
the
that
bias.
all the images of same size will be of same size.
No, images are already of fixed size 28 cross 28.
Okay.
So we are
Colors are
doing,
assigned.
yeah, someone want to say something? Yeah.
So I was just making a guess. Like colors are assigned values from 0 to 255. Like once, something along those lines.
No, even grayscale image is having all the values from 0 to 255. Mhm. In color only, it will be 3 channels.
Maybe model train will be training of the model will be faster and for
How?
better performance.
How? How? You are saying something right, but how?
Um, Sir, if the model gets maybe model lands in the overfitting, this normalizing can help not to go into overfitting.
So basically, as you have seen, your network is nothing but it is a filters and a convolution operation it has to perform. In convolution, what we do? Matrix multiplication, yes or no? So it
Yes.
is already clear to us that these numbers are in this range 0 to 255. If we scale these numbers into the range of 0 to 1, then the multiplication values will get smaller actually. There will be small numbers to multiply actually. That's why we are going to normalize this data. Okay. So there is a one scaling 0 to 255. We are just scaling down these values in the range of 0 to 1. If it is a number 255, then its value would be 1. If it is a number in between something, let's say 124, then its value will be 0.5 something. Okay. So now you understand. So we are going to do this normalization so that all these values get converted into this range, so that there would be a lesser computation power utilization. Okay. So that's why we are doing this. Then we have to one hot the encode our labels values. Okay. So what is this one hot encoding? I will just tell you with example. So you just type as this moment, just you write this to categorical. This is, we have just imported a library from here, right? From the Keras to categorical, right? Now you just type here to categorical and pass this y train and y test over here. And number of classes will be nothing, just y test dot shape 1. If you type 0, it would be 10,000 values. If you type 1, it will give you the number of classes. So how many classes are there? 10 classes. Now let's say I just print this y test 4. So I am here printing this y test 4 and it is giving an array and with all these values. And you remember I just written over here y test 4 earlier as well, right? So what it was giving? It is actually a train, not test, and that was a Y test actually. So Y train 4 was giving me one number actually. Now it is changed actually. But earlier it was giving you what? It was giving you a number actually. So what happened here, student? We are going to perform one hot encoding of this all these numbers actually. So one hot encoding means uh, basically wherever it is 4, so it means all other will be set as 0 from 0 to 9. All other digits are set as 0 and that fourth index will set as 1. If it is a index number 5, then this would be set as 1 and all other will get a set as 0. So this is called one hot encoding of over all the labels that we have. You understand this? Why we need this? Because computer will not understand what is 9, what is the relation between 7, 8 and 9. But it will understand that if I store them in the form of this array and for index number 4, if I set this 1, then it can understand that this is a number 4 and 5 is how much away from 4 and 6 is how much away from this, because it can understand 0 and 1 form, right? Okay, is it clear?
Yes, sir.
Okay, then next step is, as I mentioned you, that we need to further divide our data, training data into training and validation set. Now you do understand? Can someone turn off their mic? Some voice is coming. Okay, so now we need to again split the data into training and validation set. So by using this command, you can split your whole data into training and validation set. Why we are doing this? Because while training, we will give training and validation data only, because computer will evaluate. So for one epoch, it will execute for training and then it will validate on the validation data set and try to see how much error is there, and then it back propagate and then will next run for the next epoch and so on. This is how it works. So, but we are not showing anything over here during the training time. The testing data will be kept as separate and we will use that testing data only at the inference of testing time. So you are able to write these lines?
Yes, sir.
Okay. Now the next step is, so till now we have formatted our data and we have tried to understand what it data is, and we have formatted this in normalized in this way. We have converted into one hot encoding, and now we have further divided our training data into training and validation set. Can somebody tell me, earlier X train was having 60,000 values. Now what would be the number over here?
80,000.
No, so X train was having 60,000 values. You
45.
you have seen over here, right? X train was
So
having total
45,000.
60,000 images. How 45?
So by default, it splits in 75 to 25 ratio.
Yeah, by default it will do,
No,
but
sir, here,
we have given the size,
here
Okay,
test
testing
size
size was given
0.2.
20%.
So it is
80%.
80-20 ratio. 80-20 ratio.
Yes,
1,000.
sir.
48.
So 48. The right answer is 48. So 80% of 60,000 is 48. Okay. And 20% means 12,000. 20% of 60,000 is 12,000. So validation data set will be having 12,000 images and training data will be having 48,000 images. Okay. This is clear, right? And if you change this ratio to 0.3, then it will be 70-30. If you set as 4, then it will be 60-40 and so on. So you can change this as per your need. Okay, let's define a very simple model with very few layers just to understand how does it work. So let's discuss this first line by line. So first we are going to write model is equal to sequential. Basically, it will be a sequential model, and we'll be going to add layer by layer to this. So we are going to first add the first layer, model dot add. So the layer name is con2d. We have already imported this at the beginning. 32 represent what? I have mentioned you today as well. What
Filter.
is it?
Filter.
So 32 is the number of filters, and 3,3 is the
Size of the filter.
size of those filters.
Matrix.
No, it is the size of those filters. So there are 32 filter, each of size 3 cross 3. I mean 3 by 3 matrix. Okay. Then we are going to mention the stride. Stride is 1. So 1 means it will move just by 1 pixel after going to convolution on the one patch. Padding is same. Same is, I mean, it will try to reduce the feature map once it will get convolved. If you type padding is valid, then it will produce the same size as of the input size. Then next, this is the first layer actually. So we need to also pass what is the input shape to this. No, can you tell me what is this input shape? What is the value of this? We have already discussed this.
22 cross 22.
Yeah, so
28
it is
input
28
size of the
comma
image.
28 comma 1. So it is basically the shape of the input image that we are going to give. If my input images are of different size, then I will give the different size to this. Okay. So whenever you will be working in some different problem.
Into 1 you told, na? So that is
Yes.
what, sir? The grayscale is for 1, na? For
Yes.
grayscale image it
Grayscale
is
is 1.
1. Okay.
Yes. Yes. Okay. If it is a color image, then it would be 3. So we will see how to use 1 and how to use 3 as well. Okay. Then the activation function ReLU. Okay. So for the first layer, we have to define this actually. So this is the first layer that we have defined. So we have just, let's say, one con layer. Then we have just this flatten layer. So after this will work, we're just going to flatten it. You know why we need to flatten this? Because we have to pass them into the next dense layer. And dense layer will accept 1D array. 1D array of feature, one vector only. Okay. And here you can specify some number of classes. So this is the dense layer. So let's say I am going to classify maybe 100. You can specify maybe 50, 20, whatever neurons you want. So these are the number of neurons in a neural network, fully connected neural network, right? So that is called dense layer. Activation, again, I'm using ReLU. Then the final layer, I have told you in the final layer, how many neurons would be there?
10.
10, because we have total 10 number of classes, and number of classes we have already extracted from here. Number of classes that is coming from here, ytest.shape as subscript 1. So it will give us 10 actually. Comma activation. Now what kind of activation we are using here?
Softmax.
Why softmax?
Because in the final layer, we use softmax.
So what softmax, how softmax is different from ReLU?
It's basically going to keep the probability between 0 and 1 only.
Right. So final layer will always be in the form of softmax. The activation will be always in the form of softmax, and it will always give us a value between 0 to 1. So now you run this model and you will see it will try to create it, and then you just write model.summary, and here you will see the overall architecture of your model, and you will also see some total number of parameter it has, and trainable parameters, non-trainable parameters, and so on. Right? So just to do this, so you can see the first layer, it will accept this 28, 28, 32 filters are there, total parameter are 320, then flatten layer, then dense layer of 20 neurons, and then final layer of 10 neurons. So you understand this? So just try to write up this and run this model summary, and you will see how your model looks like. And tell me, once you are able to complete this, just thumbs up. I want to understand how many of you are able to do this till this.
Sir, I have an error with invalid dtype and array.
Where you are getting this error?
Model add con 2D.
Okay, might be you're not able to properly. Does anybody else getting similar error?
No, sir.
Okay. So Komal has completed. What about others? I want all of you to raise your thumbs once it is completed so that I will move to next. So where we are? What about others? Are you able to complete?
Yes, sir.
Yes, sir.
So thumbs up once you're able to complete it so that I can understand that you are with on going with my pace. So many participants are there. I can see only one or two thumbs up. What about others? Tell me if there is any problem, difficulty you're facing. Let me know. You might get some unweird error, but if you have done step by step, I don't think so. You will get some error. I just tested it before showing it to you. So there should not be any such case. Should I move next? So any question, any doubt here till now? So Neeraj Sharma, can you turn on your mic and tell me where are you? How much you have completed? Hi Neeraj, can you hear me?
Hello, sir.
Yes.
Sir, I asked a question at the beginning of the मेरे को ये मैं सुन तो रहा हूँ लेकिन मेरा ना फर्स्ट एरर ही सॉल्व नहीं हुआ ये
Okay.
when we were importing the files I asked you my
Hmm.
Google Colab is showing me keras.models पे अंडरलाइन बन के आ रहा है और वो बोल रहा है कि import is not available या कुछ तो ऐसे बोल रहा है
ये वाला ना?
हाँ
तो ये सेम आएगा, कोई दिक्कत नहीं है, इसमें
ओके
कोई प्रॉब्लम नहीं है। ये देखो
ओके
आ रहा है ना यहाँ
ओके
पे भी। दिस इज नॉट ए एरर, दिस इज जस्ट वार्निंग।
ओके
ओके, others do have any other problem? Are you able to complete till this?
Aman sir, we are having few queries in the chat box if you can
Okay.
take those.
Yes. From sklearn model selection import this. Sir, please show training and validation code. Yeah, I'm just going to move next. Can you show the code? Is it module? The train and validation. Okay, training and validation. I'm just coming. Maybe you're not able to import this properly, right? So just try to, or I will put this in the chat if you are doing some mistake. Let me just copy here. Hmm? So just try to type it as it is. Maybe some variables mismatch, X train, X is capital, Y is small here, just to understand that these two are different actually. Hmm? So take care of this and I think it will work.
Excuse me, sir. Sir, will you share
Yeah.
this file? Actually, I have joined late, so I'm not actually executing along with you. I'm just understanding it and writing it down.
So whatever till now we have done, I will just copy paste and I
Okay,
will
sir.
not share complete because if I'll
Okay,
share,
sir.
nobody will do this.
Okay, sir. Thank you.
So I
Yeah,
want
moreover, ma'am,
everyone.
you will get the details in the end of at the
Hmm.
end of the workshop.
hmm.
Okay.
So for this right now, so just import this, load the data set. Okay, I want everyone to be completed till this. Then we will move next. If you miss one step, then won't be able to understand next actually. So it says sequence. Then all these are just training, just to understand. Then formatting the data. Okay. And then here we will do separating the data into training, and this is I have already given. Let me do it again so that you will follow the sequence. Then defining your own simple shallow CNN network with just one con layer, flatten layer, dense layer, and final layer. And then you print just model.summary. So it will show you your type of model is. So till this, everyone can understand. Huh? Okay. Then the next step is compiling our model. So once model is defined, we will compile our model. So for model compilation, we will pass some parameter, like we will give what kind of loss function we want to use, what kind of optimizer we are going to use, what kind of metrics that we want to evaluate. Okay. So right now I'm giving these parameters. So loss is categorical cross entropy. If you're going to solve some regression problem, then you might be using mean square error loss. If you're going to use some other focal loss, or it could be any other type of loss. So there are different kind of loss actually. So depending on the kind of problem you are working on, you will specify the kind of loss. So categorical cross entropy loss is used when we have uh, some classification problem. If you want to solve a classification problem where there are two number of classes only, then we use binary cross entropy loss because there are only two classes, 0 and 1. So we use binary cross entropy. But here we have 10 number of classes, so we use categorical cross entropy loss. So with this, we'll compile our model. Optimizer, there are so many optimizer, stochastic gradient descent, Adam, and there are so many other. What is the use of this optimizer? Why we are going to use this? You might have heard during these lot of sessions in this talk. So there is a term optimizer. So why and what is the need of this optimizer?
It will fine tune the parameters.
So optimizer will basically help us to
Tuning the
optimize the
parameter.
weights, right? Fine tuning the parameters and optimize the weights of those filter so that we could converge our loss function to minimum value. Okay, so initially maybe a loss would be having some number, let's say 80, 0.8 or 80%. Then during the back propagation, all these weights get adjusted so that we could get the proper or very less loss and higher accuracy. For that, an optimizer internally will work out and try to figure out what numbers it has to change, how it need to change those filter values so that it could minimize the loss. So that is the meaning of this optimizer. And metrics means what kind of metric we are going to pass to evaluate its accuracy and all. So once model is compiled, so we'll execute. Then next step is to train this model. So this is a very simple model. So we are just going to train it like this. So you just type uh, model.fit xtrain ytrain, comma, we'll pass this validation data x underscore validation, comma, y underscore validation, epochs 10, batch size 200. Who wants to explain these two terms to me? 10 epochs, batch size 200.
Epoch basically means how many times it will iterate. So 10 times it will iterate.
For 200 200 times.
And what is
So
this
here
200?
10 batch size is 200.
What is the meaning of
So
this?
we'll be so we have the train x train is equals to 48,000 also. So for one
Hmm,
epoch it will train 200 images. So in next
very good.
epoch it will train next
Hmm,
200 images.
very good. So basically it will create the batches of your entire data set. So as you mentioned, 200 images, but no. So what it will do, it will divide your entire data set into 200 batches actually. So basically there will be a 240 size of 200 batches. Okay. So that will give you
Okay.
48,000 images actually. Huh?
Okay.
So 10 epoch means on the entire data set, it will execute for 10 times. So for first time, epoch 1, it will show all these images to the model and it will compute the loss function, accuracy, validation accuracy, and then validation loss. Then it will execute for the next and so on. So just click on this and it will show you the training, how it proceed. So some error is coming. Argument target node must have the same dimension received. Why this? Let me just try it from the beginning. Might be I have missed some step. Does somebody else also getting same error?
No, sir.
Oh yeah, then let me just try it. It's working now. Hmm? So here you can see how your model is getting trained. Huh? So you understand this concept? If you have some questions, you can ask me here.
Sir, I was also getting the same error. How did you solve it?
Or you just try to run it one by one from the beginning because might be while teaching I have executed some cell twice or something. So just go from the beginning and execute it. So maybe it will get
Okay,
solved.
sir.
Hmm. Okay. So you can see
Sir,
our model. Okay. Yeah.
sir,
Yes.
so
Yes.
can you please show the model.compile portion
Yes.
after the model equals to sequential and something?
I have put that in the chat as
हाँ
well.
सर
If you
समरी के बाद बोला
if you go here, uh, this one, right? Model dot summary and then model
after
dot
this.
compile.
Okay,
Yeah. In the
thank you,
chat
sir.
window, you can see model compile and then model fit. Okay. And so once compilation is done, you could see model is getting trained for 10 epochs and you could see this answer. Now there are few things you can do over here. You can increase the number of epochs, let's say 20, and let's increase the base size to 250. Okay, let's execute it again. So what will happen actually?
Accuracy has increased.
Accuracy has been increased to after this 17th epoch, it is totally reached to 100 actually, huh? So you can see with a
Ma-
very small network, we are able to achieve 100% accuracy on this MNIST data set using just for only 20 epochs.
Sir,
So
in
this
my case,
is,
it's coming after 14 only.
yeah,
Like
it
from
it will vary. It will vary. There will be no fixed answer for some. So everyone's answer will vary. In some cases, it will change some number. In some cases, it might show 98.99 something because all of this is optimization process actually. It's not a one discrete result. It is a kind of a large optimization of, as we have discussed, there are a lot of parameters inside the network, right? So it will change from in if you execute the same thing in different place, it will change depending on the kind of computer architecture version you're using. So it will vary. So no need to think on that, but you should know that it will vary. Hmm? So you could see loss is getting minimized after every epoch, and these are validation accuracies. So so who will explain me this accuracy, loss, validation accuracy, and validation loss?
So validation accuracy is like you're writing a mock test. How you got that? It is just like an example.
Hmm.
The
Hmm.
accuracy is your main exam.
No.
No, okay.
So basically, yeah, you're trying to relate it, but this is basically training accuracy. Okay, training accuracy and training loss, and this is your validation accuracy and validation loss. So you remember we have divided the training data into training and validation data. You could say this is the accuracy when you are studying in a class, and this is the accuracy when you are appearing for a mock test. Okay, so you can relate like this, but the final accuracy of this model will be validated on X test data that we have already split it out earlier. So we'll see in the next part, and and you can also plot it like this. So you will see here. So because we are having these matrices accuracy and loss, validation accuracy, so we can plot them as well, like how they are coming, right? So you can see training accuracy is coming like this. Validation accuracy is little less than the training accuracy. Hmm? And you can also plot your loss as well, loss versus validation loss as well. So let's do it over here as well. So just you need to type this, type here loss, validation loss. So what do you understand from the graph that how after each epoch, how your loss function or accuracy is changing? Training, validation, this and this. Okay. So you could see how this is your validation loss and now this is your training loss. Hmm? This is how it is getting decreased and this is how it is sometime going up, then going down. Okay. So you just plot these graphs. Let me share with you. This is a very simple try examples to understand how things work. Hope you understand this. The main intention of this workshop is to understand the very basic concepts so that you can then later on design your own network and build your own methods and deploy them on different problems. Hmm? So is this clear to you? Are you able to do till this?
yes, sir.
Okay. Any question here? So these are legends actually. Whatever you will type here, training and validation, it will be shown over here. This is the location that is upper left. You can plot in upper right. You can make them on this part, on this area, or so on. Hmm? Lower left, lower right, and so on. Then plot.show will just show that particular plot. You can also modify this, have a grid inside this. You can change the range of these X and Y axes as well, and so on. Hmm? Okay, so next step is to evaluate this finally. As I mentioned, for evaluation, we will use which data? Testing data. So till now, we have not shown this test data to our model. So now we'll pass this test data, we'll show this test data to the model and we'll try to see how the results are coming. So we'll write like this. So whatever the accuracy or score will be coming, we'll subtract that from 100 to just get what kind of, how much percentage of error we are having actually, right? So we can see this using this model, we are able to achieve 0.9761%, 97% of accuracy and 12% of error, or you could say that is 1.80% of the accuracy. Sorry, baseline error. So 97.61% is the accuracy, and this is the baseline error of this model. But it was showing us that there is 100% accuracy of the model. So why it is showing 100 over here and why it is showing 97% over here? What is the reason?
Yeah, above is trying error and this is the test one, no?
Yes. So basically during training of our model, we have not shown uh, testing data. Okay, training data is the data that is used for training the model. So model already knows for this image, this is the output. For this image, this is the output. And initially it will give some wrong answers, but with practice, with training, it will try to understand those images and then it will just try to have all these and then finally it will give us the right answers. So that's why training accuracy could reaches to 100% once there is no loss. Okay, but testing is your final exam. So final exam will always may not be having all the answers, all the questions, those you have studied during your semesters. Okay, it could be having some answer out of your syllabus and something, right, that you might have not heard. Or similarly, in this way, it could have seen some images, those it has not seen earlier. So it was not able to classify them. That's why the testing accuracy always come like this. Is it clear?
Yes, sir.
Okay, so till now, we are able to just define one simple model with all these steps and we are able to, so let me just revise it for you. Or someone wants to share their screen and just to discuss, maybe it would be more better so that I can understand that you're getting something. Can someone share their screen and explain all these? I will also help you to explain that. If you could share your screen and let's discuss what you have gone through. You are allowed to share your screen as well, right? Can someone share your screen or should I type the name? Who wants to be volunteer? It's okay if you don't understand it completely. I will tell you, I will explain you. No one? Okay. Who has shared this screen?
So
What's
it's
your
me.
name?
Can you see? My name
Okay.
is Mansika. Sorry.
Okay, great. Yeah. Can you go on to explain what we are discussing?
So can you just tell me what
Yeah.
exactly are you able to see? Like can you see that CNN workshop dot IP and YNB?
Basically, I'm able to see your Teams window. So maybe you can minimize this and just open this. You can minimize
Oh,
this. Yes, but no, I don't. We're not able to see. If you go to the share button and in the share button, you click on the windows or screen only. Sorry, screen.
just a minute, sir.
Hmm. So let's do it quickly so that we can then move to next problem.
So now
Yeah,
can you see?
now I can see. Just try to explain in different steps that what we have gone through.
So the first code block basically shows that we have imported the various packages that we'll be using, like
Mm,
numpy, matplotlib.pyplot, and the keras model from the TensorFlow package. And then in the next code block, we basically move on to the data set that we want to import, and that was in our case MNIST.
mm,
And then we divided the loaded the data set xtrain and ytrain and xtest and ytest. And basically the ytrain, as you explained earlier, basically is going to contain the output labels, and the test one also, and in the train one also.
mm,
So in the next code block, we simply imported the matplotlib package, and then we printed the training data. This
mm,
and then we used a plot imshow for like the four one category, the class, and then
mm,
binary is for the grayscale,
mm,
because we wanted to print the data set in the real way. And then we
mm,
plt.show is basically going to plot it.
mm,
And finally, we labeled it. So this is the output we got, output we get. And
mm.
after this, we basically moved on to find the shape of xtrain dot shape. We found that it is 60,000 comma 28 comma 28. It's a 28 by 28 matrix. Yeah. Similar for the Y train and the X test and the Y test.
Right. Mm,
And after that, we basically did the input shape, which is basically going to enter the shape that it's 28 comma 28
mm,
comma 1.
mm,
Yeah, 1 for because we wanted in the grayscale.
mm,
And then we converted them to the float 32 because
mm.
this is what we are going to use. And then we divided the 255 because we wanted to normalize it from 0 to 255 to 0 to 1.
Mm.
So both the X train and the X test. And then one hot encode outputs using the two categorical. It's basically the Keras utils. So I
Right.
simply kept this two categorical. So yeah, it's going to basically keep all the value 0, and the one that we wanted will be 1.
Right.
Okay. And then from sklearn.model selection, we imported the train test split. So basically we are going to like how we're going to split it. So we kept the test size as equal to 0.2 because 80-20 ratio is what we wanted. We could have gone with 70-30 or like 60-40 as well.
Right.
After that, we wanted to our model to be sequential. So we went with sequential. Then we added the convolutional layer 2D, and we
Mm,
added the stride. It's going to shift to the next pixel one time. And this 32 is basically the filter, and 3 3 is the 3x3 matrix that we wanted. And padding, we're going to keep it same. Activation function would be the relu, and the input shape, we have to specify the input shape. So we have already done this in the
specified.
above one.
Mm,
Yeah.
mm,
After that, we're going to flatten it because of course we wanted to put it into our final dense layer. So we'll flatten it, and then we dense like we added the dense layer. And this time also we kept the activation function relu. And
mm.
after that, also there is this final layer, and this final layer will always be like the softmax because we wanted to keep our probabilities from 0 to 1 only. So that's why.
Right.
And then after we run the model, this is what we will get. And finally in the next code block, we'll write model.summary to basically give an idea about our model. And this is the output. It basically specifies the different layers and the output shapes and the parameters. And then we'll compile it. So the loss function would be the categorical cross entropy. It will be categorical because we have multiple classes, like 10 classes are there. We could have gone with binary also if there were only 2 classes. Optimizer is the Adam optimizer, and the matrix is the accuracy function. So yeah, it's going to convert the value to the minimum losses. And then we'll train our model. So history is equals to model.fit, xtrain, ytrain, validation data is we are specifying it as x um, val and y val, and the epochs, the number of iterations would be 20, and the batch size is 250.
Right.
And then we'll plot it. So in the plotting, the first plotting we did was the for accuracy and train accuracy and validation accuracy. And I think this one is wrong. I should have gone with validation accuracy only.
Hmm.
Yeah. And then the legends, I haven't specified the legends here, but
Hmm.
you in the one you shown, there were legends.
Hmm.
After
Right.
after that plt dot show, and then the last one was for the train losses. And
Hmm.
then finally we'll evaluate our model. So model dot evaluate x test comma y test, and the baseline error we specified, and the 100 minus course, it's basically going to give us the baseline error as 1.84%, and the
Hmm.
accuracy is 0.9783, and the loss is 0.1064. Yeah.
Very good, Mansi. Yeah, this is what I wanted to hear. So everyone get the summary of all that what we have done right now. Thank you. Thank you. I will share my screen now.
Yeah, thank you
So
so much, sir.
yeah, thanks. So this is a basic kind of a simple network that we have built upon and to see. So now let's create some little more complex model. So it will be nothing but it will be a repetition of con layer, max pool layer as we have seen earlier, right? So just after this, you will I will just give you this code so that you can just type and paste, compile it. And so basically this would be a little large network that we can see it has con layer of 32 filters. There are two different con layers now, then max pool layer as we have discussed earlier, and then con 2D, and then flatten layer, then dense layer of 500 neurons, then 100 neurons, and finally we have softmax clause. So you just do this and do the same process. After this, you copy paste all other things as it is, like model.summary, and then model.compile, and then you can see the history of this model. Hmm? So you could see you will be soon get some better results with some less epochs. You will get more and more results. Hmm? So just try to have this. Tell me once you are able to complete it. Rest everything will remain same, right? Model.compile will remain same, model.fit will remain same, and this plotting will remain same.
So I don't know why, but it's showing an error. Says that input shape is not defined.
Just a minute. This one, right? For me, it's working. So maybe if you might have reloaded or something, just click on this again, input shape, run this cell again. Maybe you will get this, but don't run this alone. Maybe you start from the beginning because otherwise it will change the data again. So maybe from the beginning, just try to click on all the cells and then you do it again. Sometime there is a problem in the collab. Our session get timed out and all these variables get deleted actually. So that is the disadvantage of using collab. But it is free of cost and we get the GPU so we can do some training and testing. So it's working now. So you can see with just 4 epochs, 5 epochs, we are almost having the same accuracy in this model as with the previous model. We have to go up to till 16 or 17 epochs to have the similar results. So this is the power of creating a little deeper network where we get more accurate results, more accuracy in less time actually. So are you able to do this now? Is it working, Mansi?
No, sir, it's still showing the same error. I'm trying to figure
Same
it out.
error. Okay. Maybe something you have missed out. Just check it. Or else you just pass it here in the round bracket 28, 28, 1. Just remove this and here just you pass 28 in the round bracket 28, 28, 1.
Yes, sir.
It will work. Okay. Then again, you can plot all these things. And one more thing I'm doing over here, that is model.save. So what happened? Let's say you have designed the model and you want to do testing maybe day after tomorrow. You don't have some testing data right now. Then you have to save your model. If you want save your model next time, again, you have to train your network. And they, while training, you will see there are some networks. Sometime we used to train them 2 days, 3 days, 4 days, and so on. So it's not possible to retrain the network again and again. So we store the weights of our model. So by writing this model.save, so you will specify the path. So what will happen? It will just inside this folder content, it will store this weight cnn.h5. You can see. So later on, next time, if you want to evaluate, you just define your model and you just load your model here. So you can see load model. So from keras.saving load model, and you will load the same model. Now we are not going to give any training, and then you just model.evaluate, pass the test data, and it will do the same job. So this is what you can do to save and load your model. Okay, so I will give you this code. We start from here. Okay. So next time you just define this same model again. And just load this and evaluate it. Okay, so this is model saving, and you can also save the weights of the model. You can only save the weights, load the weight. So there is a difference in model.save and model.save weights. Can somebody tell me if you know? So basically, if you go for model.save, what will happen? It will save the entire architect of the model and the weights of the model. But if you save only model dot weights, it will save only the weight value, the metric value, the weights value inside that, and biases value it has learned through the training process. And next time you need to define the model, and with the same model you need to load the weights. But if you just have store complete network, then you don't need to define the model. You just need to type this line to get all the model architect and its weight inside this. Okay. But if you are just storing the weights of the model, then you have to use the same model architect to load these weights so that you can use it. So that is the difference between model.save and model.save weights. Okay. Then there is another technique for training, that is model checkpoints. So why we use checkpoint? So what happens sometime we are training a model, let's say we have set it for 1000 epochs. So now it is not our duty to just sit and watch at till what epoch the model is giving us the better result. Like we have seen, we have set epochs 20 and after 15, it was giving us the 100% accuracy. Okay. So it is not possible. We are also not sure that at what epoch the model will learn completely. So in that case, we use model checkpoints. So what it will do, it will during the training, it will see for consecutive 2-3 epochs, if there is no change in the loss, if accuracy is coming same, then for that particular epoch, it will just try to save the weights and it will early stop for us. It will stop it so that it will not execute further. So it will help us to save the weights and so that later on we can use. It may be happen that after 20th epoch, the model again start downgrading. It may be happen or it will get overfit. To avoid this, we use these model checkpoints and later from those checkpoints, we load the same model and evaluate it. Hmm. So you can practice later this. I will give you this code. Okay, right now I'm not sharing. I will share this notebook with you so that later you can process. So one more model I want to discuss that is very popular as we were discussing earlier. That is VGG network, right? Okay, so I will just explain. Maybe if time permit, we will execute. Otherwise, you can do it later. So Keras has already defined these model. So you can load like this from keras.application.vgg16 import vgg16. Okay. So here you just define vgg16 is equal to model and model.summary, and you will see this complete model will be shown over here. It will download all the models and weights and it will show us the complete VGG16 model architect as we were discussing in our 2-day session. So do you remember what was the input size of the image for VGG16? We were discussing today. It was some number. Do you remember that? Like for MNIST it is 28, 28 cross 28. What is the input image size used for VGG16? It was 224, 224, 3. So why it is 224, 224, 3? Can somebody tell me? Are you listening me?
Yes, sir. 3 is for the RGB, 224,
So basically 3 is the RGB. So this model is trained for the ImageNet actually. And these are the weights coming from the ImageNet dataset. Okay. So that's why it is coming like this. So by default, you take the weights from the ImageNet. Now, do you think, can you directly employ this model to our MNIST dataset? Will there be any problem or will it work or not? Any answer from anyone? Hello. Can we use this model directly for our MNIST classification problem?
No, sir.
Why?
So the
The answer
images are in
lies here.
grayscale.
The images are in grayscale. First of all, we need to convert them into color channel. We need to have this size. We need to rescale them. And then also in the final layer, we have to increase the, we have to decrease
Classification.
the classification number of classes. We have only 10 classes. So
10.
we can't use it directly as it is. That's why we need to change it a little. Okay. So this is called transfer learning actually. So basically what we do, so if you go to our VGG network, there it is. Yeah, this one. So this part till pool 1 by 2, after this we have all fully connected layer like FC fully connected layer. So we will just take the model up to this part, and after this we will define our own fully connected layers and our own softmax layer to get the results. Okay, so that's why we'll write it like this. Instead of taking this complete, we just write include top is equal to false. So it means it will not take the last fully connected layers, and it will take till the last pooling layer. So we will just branch out our network. Okay, and here you see input shape we are giving 224 comma 224 comma 3 model dot summary. So it will give you your model like this. Now you can't train this model from the scratch. So what you do, you will set all these layers trainable false. So because there is no need to train all these layer, it is already trained very well on some other data set. So you just modify and retrain the final layers. Now on doing it on a collab, it is very difficult to execute on 60,000 images actually. So I did a very small data set. Out of all these 60,000 images, I just selected 1,000 images only. So this is just going to reduce the size of the data set so that you can just do it quickly. Okay, but you can use 60,000 if you can just try to figure it out. Okay, then we have to change the dimension of this network. So what you need to do, so we are just having 224 comma 224. So we need to just expand the dimension axis so that we can include the 3 channels. Okay, so by using this line, and you can just reshape your images into 224 into 224. So it will convert all your images 28 cross 28 to 224 224. And then here you just try to see the shape. You can see here for all those images the shape got converted to 224 comma 224 comma 1. Now next thing is you need to convert these grayscale images to RGB images. So it means you need to convert into 3 channel image. So for that you just need to concatenate this image for 3 times. So you are just going to concatenate them so that the image would be of 3 channels. So later if you print the size of this, you will see it is 224 comma 224 comma 3. You understand this? You can do it via this, or you can also use tensorflow.image.grayscale method, grayscale to RGB method to do this. It will also do the same job. Okay. Now we'll change some final layer of the network. So as I mentioned that we will just use the last layer of this model. So model dot output last layer. So basically this will get the weights of this last layer, that is the max, that is the block 5 underscore pool layer. Now after this you will add these fully connected layers. So you could see here you will flatten this. So that is the first thing we do. Then we do add the dense layer of 100 neurons. Then we add the second layer of 10 neurons with activation of softmax, and then just we will redefine our model like this. So model will be equal to model inputs will be model dot inputs, that is already defined at the beginning, and output with output, what is the next parameter will pass, that is output layer, this one, the final layer. Okay, so this is what it will get passed to this model. And then if you print the summary of this model now you will see your this classification model get changed over here, right? So you could see there are two dense layer, one with 100 neurons, one with 10 neurons, because we want to just convert into this form. And now if you run this using some optimizer, and we can also update the optimizer like this. So you can see earlier we have just mentioned Adam. Now we can specify some learning rate, some momentum, some decay into this, and we can pass on this. We can change these learning rates, momentum and decay as well. And then we fit the model. We will again do the training and testing, and we'll see the results over here. So this is how we can use existing VGG networks to solve the MNIST problem. And if you want to use RESTnet, Inception, GoogleNet, so everything is there on the Keras. You just go to Keras documentation and you will see, just you write keras.application.restnet50, import restnet50. RESTnet 150, just you import that. So same way you can perform all these exercise by doing all these steps and import and use the transfer learning. And then the beginning example, as we have discussed, you can create your own model or you can design your own models like this, define the layers, add it, try to validate it, check the results, modify it, and try to understand how it works. Okay. So with this, I think our time got completed. If you have any quick doubts, you can ask. I'm going to share this with all of you so that you can practice it later on. Okay. Do you have any questions, guys? Or you got tired? Did you enjoy it? Did you learn something? You can discuss your feedback.
So thank you, sir, for this interactive and informative session. So if anyone is having any doubt, you can type in the chat or you can unmute yourself and you can share.
I think I'm not able to share it. So I will share with you, Bilasha, so that later you can pass on to these, or maybe in the some group chat. I think I'm there.
Sir, we will share you a link with you. We'll share a
Okay.
link with you to upload your contents.
Okay, okay. Then that's fine. I will upload over there, huh?
Yeah, sir, sure. So thank you,
Okay.
Aman, sir.
Thank you.
So it's
Thank you.
nice to see you again.
Thank you.
Sir,
Okay.
can you please share your email ID, or if we want to ask
Yes.
you something or some
You
help
could
in
note it
projects?
down. Could note it down from here. Just a moment. Okay, so it's you could note down my official email ID. That is aman.kamboj@michelin.com, and my personal email ID amankamboj, it's double J at the end, @gmail.com.
Thank you, sir.
And you can connect me on LinkedIn. Just type it and
Thank
search
you,
it.
sir.
You would find. Okay. Yeah.
Thank you
Thank
so
you.
much, sir.
Bye bye. See you. Bye bye.
Thank you, sir. Thank you so much.
Thank you. Thank you.
As we have already shared, we are going to share the recordings and all other material at the end of the STC.
Okay, ma'am. Thank
Yeah. So all of you are requested to mark your attendance on this link. So thank you all for today. We will end our meeting over here.